Okay, step 5 deals with the end behavior. And so once again, we're looking at what's happening as x goes off to infinity and as x goes off to negative infinity. And we know from what we learned about polynomials that as x goes off to infinity or minus infinity, my function r of x, which once again we can use the reduced formula, the numerator is governed by the leading term there, 2x squared. The denominator is governed by the x squared, the leading term down there, and that ratio is 2. So we know from section 4.1 that we have a horizontal asymptote, y equals 2. But once again, if we perform a more detailed analysis, we can see how the function is approaching this horizontal asymptote. So to do that, we're going to use long division. Since the degree of the numerator is the same as the degree of the denominator, I can rewrite this as sort of an algebraic mixed number, if you will. And to do that, I need to do the long division. X squared plus 0x minus 4, which is the denominator, divided into the numerator, 2x squared minus x minus 3. So I multiply what times x squared gives me 2x squared. The answer is 2. So I get 2x squared plus 0x minus 8, and then I subtract. 2x squared minus 2x squared is 0. Negative x minus 0x is negative x. Negative 3 minus negative 8 is a positive 5. So that's my remainder, which means that I can rewrite my function r of x. Instead of writing it this way, I can write it as 2, which is my quotient, plus my remainder over my divisor. And so this is what I'm going to use then to analyze the function as x goes off to minus infinity and x goes off to infinity. Okay, so here's our function rewritten. I'm going to look what's happening as x goes off to infinity. So I can think of plugging in, say, x equals 1 billion. So I look at my r of x. It's 2 plus, and in the numerator I get negative 1 billion plus 5. And on the bottom I get 1 billion squared minus 4. And so I know that 2 is the vertical asymptote, so I want to take a closer look at what's happening here with this leftover piece. So if I take negative 1 billion plus 5 over 1 billion squared minus 4, well, the thing that really matters up top is that negative billion. The thing that really matters down here is the billion squared. Once again, you can think of this as a polynomial. The leading term up top is the negative x. The leading term on the bottom is the x squared. So that's what's going to run the show. And I simplify this, I get negative 1 over 1 billion. This is going to be a very small number. The larger x gets, the smaller this is going to be. But since it's a negative over a positive, it's still going to be a negative. And so we would say here that the r of x is approximately 2 plus this leftover piece, which is a very small negative. So we could write as x goes to infinity, r of x is going to 2 from the left because it's a little bit smaller than 2. And what does that mean geometrically? Well, we know from the theorem in 4.1 that we've got this horizontal asymptote, y equals 2. If the r of x is 2 plus a small negative, that means that the y values on the graph are a little bit less than 2, which means the graph is underneath the horizontal asymptote. All right, let's look at x going to negative infinity. So we can imagine x being negative a billion. So I plug that into the function and see what I get out. I get 2 plus, and then in the numerator I have the opposite of negative a billion, plus 5, and in the denominator I have that negative billion squared minus 4. And so once again I want to figure out what's happening with this leftover piece. So in the numerator there I've got the opposite of negative a billion, well that's positive a billion. And adding 5 to that's not going to really change it much. And then in the bottom I get the negative billion squared. And the 4 doesn't change that much, and so that's 1 over a billion. So as x goes to negative infinity, this ratio is going to get smaller and smaller and smaller, but it's going to be positive as we do it. And so the r of x is roughly 2 plus a small positive. And so we could say as x traipses off to negative infinity, the f of x is coming to 2 from the right-hand side. It's a little bit bigger than 2. And what does that mean geometrically? Geometrically, oops, it's supposed to be at y equals 2. Remember on the graph the function values are the y values. So as we plug in like x equals negative a billion, what we're getting out is 2 plus a small positive, which means that the y values are a little bit bigger than 2, which means the graph is a little bit above the line y equals 2. So that completes step 5, discussing the end behavior.